Hey, welcome to Probability and Statistics. Today we're going to do dependent probabilities or conditional probabilities. So we have this chart of where a wafer was taken and the number of contaminants that it has. So if you're in a manufacturing facility making silicon wafers, the probability of it being in the center and having zero contaminants is 30%, and so on and so forth. Or being from the edge and having zero contaminants is 10%, and so on and so forth. We have the totals over here of each one of these, and you'll see how this all comes into play. So in this problem, A is going to be the chance of 4 or more particles on a wafer, and B is the chances of the wafer being from the center. So for the very first part, probability of A, the way to do this is actually not too bad. So the probability of having 4 or more particles, if you're looking up here, then you'll see that it's excuse me. Probability of 4 or more particles is equal to this row, which is 4 particles, and this row, 5 plus. So it doesn't matter where they're coming from, just that they have 4 more. So you have this entire row, 5%, and this entire row, which equals 10%. So the probability of A is equal to 0.5 plus 0.10, which is equal to 0.15. So the probability of something having more than 4 particles. So moving on to the next part, probability of A bar B. The way to read this is the probability of A given B. So the probability of 4 or more particles given that the wafer is from the center. So the equation for this is actually the probability of A intersected with B divided by the probability of B. So when you look at this, you would kind of think it's a union, but it's not. You have to use this equation here because it cleans it up and makes it fall out right. Really, I don't want to go into detail about where this equation comes from, but just remember it's not a hard thing to remember, and you'll be just fine. So the probability of A intersected with B. So the probability of 4 or more, and in the center is 7 plus 4. So 0.40 plus 0.07, 4% and the 7% right here, 4 more and from the center, all over the probability of B, which is probability from the center, which is equal to 72, this entire row right here, 0.72, which is equal to 0.153. So this is the probability of having 4 or more contaminants and being from the center. Okay, so now the probability of B. We actually just did this kind of foreordering of the question, but this is equal to the probability of being from the center, which is 72. So I'm just going to skip that to 0.72. So now the probability of being from the center, B, given that you have 4 or more contaminants. So this time it's probability of A intersected with B all over probability of B. Now you'll see that between these two, the numerator never changed. It's still the intersection. And it doesn't really matter because an intersection, no matter how you order it, will always give you the same value. So you just change the denominator in order to get the new probability that you need. So in this case, 0.04 plus 0.07 all over the probability of B, which is, I'm sorry, probability of A. There we go. That makes more sense now. Yeah, the denominators, now you can see that the denominators are different, but the numerators stay the same. I'm sorry, I don't know why I wrote B right there. But so yeah, probability of A. So the probability of A having 4 or more. So you take both of these two columns and take their totals. So 5% and 10%. 0.15, which is equal to 0.733 if you calculate that out. Okay, there we go. So now, again, the probability of A intersecting with B, we've done this 2 or 3 times already, 0.04 plus 0.07, which is equal to 0.11. Man, this problem was messed up. But one last deal that we haven't done, probability of A union with B. So the combinations of A having 4 more and or having B be from the center of the thing. So we have this entire column, which is equal to 72, plus these 2 rows, which is equal to 15. But we can't have these overlap because they're both going to overlap right here. So we have to subtract one of these out. Otherwise, you include it here, and then you include it when you take these two, when you do the union of something. So in order to do that, we have 0.15, which is the probability of 4 or more, plus 0.72, which is the probability of from the center, minus the overlap, which is 0.11, so the 7 plus 4 right here. And this will give you 0.76. And that's how you do unions and intersections where you have a dependent thing. The main point of this problem is these two right here. Just remember these. You can get all this other information from some other example, but these two, the givens, are the difficult part. And just remember this formula. You have the intersection of the two conditions that you have divided by the probability of the one that you're trying to, the one that is given. So A given B, use the given variable down here.